In this slide, we are going to look the second example, which is the fitting of FOPDT model. Here's the process we are going to consider in this example. So consider the feedback control system for the stirred tank blending process shown in this figure, and the following step test. So this is the step test, step input, and the result. The controller was placed in manual, which means it is under open loop, and then its output was suddenly changed from 30% to 43%. So if we look at this diagram, this is the controller, and P is the controller output, XP is the set value, and XM is the process variable which being fed into the controller. So under open loop, we will disconnect the controller from the rest of the system. Here's the block diagram to represent the scenario we are discussing about. So we have the controller here, and we have the following block diagram to represent the elements connected to this loop. By open loop the controller, which means the controller output has been open here. So we can manipulate the controller output here by changing the value of controller output here, and it will affect the rest of the process, GIP, GV, GP, and also GM. And the feedback from GM will be fed to the controller. So we open this point, and then we change the controller output from 30% to 43%. So the resulting process reaction curve is shown in this figure. This is the controller output we manipulated just now. We move the existing value from 30% here up to 43% in a step response function. By observing the output, we can see the output or the measured value here changes from 35 to 55 due to the step input, which is equivalent to the mole fraction changing from 0.1 to 0.3, which is not relevant to this example. The question is determine the appropriate process model to represent the transfer function involving this process, GIP, GV, GP, and GM. So we are going to represent FOPDT. We are going to estimate the FOPDT to represent this 1, 2, 3, 4 blocks, which represents the process model.